Okay, here's the first lesson. Voltage. The subject of this entire lesson is going to be voltage. Now you might say, oh, what the heck, I don't know anything about electricity. What am I gonna... Perfect. That's the prerequisite. If you know nothing about electricity, this is the level at which you should start with me. And there are three very important units in the field of electricity: the voltage, the resistance, and the current. We are going to start with voltage because from the voltage you as a concept you can see the other two being a consequence or related to the voltage, but it all starts from the voltage. We have a voltage supplier, we have yet another voltage supplier, then we are going to have instruments that measure voltage, and we are going to have something that uses the voltage, which is a small lamp. Here we go. Now, to make it very, very fast and simple to see, we take the lamp, we hook it up to our voltage supplier, which is this little guy, and we're gonna see what happens. We have a red wire and a black wire. They stand for plus, the red wire, and minus, the black wire. Or, as we will call them later on, this is the positive voltage or the voltage supply, and this is the ground, which is 0. For now, just take them as plus and minus. This lamp doesn't care about polarity, whether you hook it up one way or another. So let's just hook it up like this. And then we turn on the supply. It glows. It's a lamp. You give it voltage and it glows. So any given device, whether it is a lamp, whether it is a heater, anything that requires a voltage will glow more, heat more, turn faster as the voltage increases. You see? Let's not blow it up. We go to 24 volts. The vendor told us by typing it here on the metal that this lamp is 24 volts. What does it mean? It means that it is rated at 24 volts, and beyond that it might burn, blow up. I'm not gonna try it. We are gonna use it during this class. Maybe at the end, I don't know. Okay. Just see this now. Voltage goes down, brightness goes down. Voltage goes up, brightness goes up. It's a very, very simple and intuitive concept. Now, do we need this to create voltage? No. I have, for example, a battery here. This one says 12 volts. Let's see whether it is visible. Can you see it? It's somewhere here, maybe. 12 volts. The difference between this one and this one is simply the fact that this one has a fixed voltage, and this one, since it's used in a lab, you can arbitrarily set the voltage you want. Okay, let's see. Oh, burns, damn it. Ah! There we go. So it's glowing at 12 volts right now. And let's compare. Let's go to 12 volts here and see whether we have the same brightness. Ah, yeah, approximately the same brightness. Okay, let's recap. We are supplying a voltage through a regulated supplier, or we are using a battery. The outlet that you have in your homes is also a supply of voltage. And the voltage that we are using now is called DC, direct current. The C is a bit misleading. It's not really the current that is direct and steady. It's really the voltage. And if we draw a chart, we put the 0 volts here, and we put, for example, the 12 volts here that we used for the lamp, and here we put time. Now what happens over time to the voltage? Well, it's steady. That's what we call direct current. Now again, it's a bit misleading. Current is not really what's steady, because you can see right now the current is 0, and as I plug the lamp the current is going to change, but the voltage is not. So we can have the current going up and down continuously as we turn on and off the switch, but what's really steady is the voltage. So what we just did now over time was having the current going up and down. What the hell? So let's now see the other side of having a voltage. Now we created it, and with this instrument now we're going to read it. You could have an instrument like this or like this. There are many flavors, colors, it doesn't matter. Usually they have this spin wheel in the middle, a display, and 2 wires with the 2 contacts at the end. You can see how the V on this side indicates that we want to measure voltage. So we spin it, and since we are measuring a voltage between 0 and 200 volts, which is about 12, 30, we set the spin wheel on 200. That's the only thing it means. It means we are telling him we're not going to measure anything above 200. So there we go. Let's measure something that is not above 200. We hook it up to the battery, and what do we read? 11.3, 11.4. It means the battery is a bit empty. It's supposed to be 12, but it's not. It's 11.3. Let's now try and supply voltage and read it right away. Okay, the multimeter reads 12.1, and this says it's supplying 12.1. Well, that's good. Let's go up. 22.3, 22.4. They're a bit off. Either this one is lying or this one. Or there is a voltage drop in the wire. So he is supplying 22.4, but at the other end, what's arrives is 22.3. 31.6 and 31.6. Well, pretty accurate. Very good. Now, in the following lessons, I'm going to use a lot of analogies with hydraulic systems to explain electricity. And the voltage in... can you actually see the board? No, really. I have to take care of this. Okay. So here goes the analogy. We have a water tank. And the level at which the water reaches is our voltage. So if we have a higher level of water in the analogy, we are going to have a higher level. We can start calling it potential. Okay. There is a potential for this water to flow or for current to flow. So if we punch a hole in this bucket, let's call it, then we're gonna have a flow. The water is gonna spill out and create a little pond. If we have a higher level of water or a higher level of potential or a higher level of voltage, given the same hole in the bucket, we are gonna have a bigger spill. It will shoot further. So we're gonna have an increased flow of current given the same hole. Okay, let's look at it again one more time. We have a device. The device is connected to a voltage supply and it will do something. As we said, it could glow, it could spin, maybe because it's a motor, it could heat, it could do many things. It could be a magnet, create a bigger magnetic field. How? By increasing or decreasing the voltage. Okay, we said we were going to try and see what happens when we go up with the voltage. Okay, it's blinding, it didn't blow up. Very good. That was the maximum. 31.6 is the maximum that this little guy can build. There we go. We have it. You learned about voltage. End of this lesson. See you in the next one.